Level design and environment design are two distinct disciplines within game development, often overlapping and sometimes performed by the same individual in smaller teams. Being aware of these differences, even when working alone, can significantly help in making progress on your game. The key difference lies in their primary focus. The goal of level design is to create a playable space that supports game mechanics, player progression, challenges, and objectives. The level should bring together your game mechanics and organize them in a way that makes progression fun and interesting for the player. In practice, using Unity and ProBuilder, this means quickly blocking out pathways, corridors, and cover points, also creating areas for jumping, placing platforms, and tweaking their parameters, and also enemy placement if you have enemies. The goal here is to test the gameplay flow and make it as fun as possible to navigate your level. The primary goal for environment design, however, is to create a visually cohesive and immersive world that tells a story, evokes emotion, and establishes the game's aesthetic. For stylized or pixel art games, you need to consider the style and visual identity of all your game assets so that when they come together, the environment looks good. Using Blender, this involves detailed modeling and texturing of assets to achieve your specific artistic vision. Alternatively, you can purchase assets from online asset stores and mix and match their style to achieve your target visual identity. Let's talk about the tools and the focus of each discipline. In level design, we focus on basic geometric shapes, quick manipulations like extruding, inserting, and beveling, and in-engine iteration. Check out my video on blocking out a level in Unity using ProBuilder. We can use these tools in Unity, and there are similar tools in Unreal Engine and Godot. These tools are great for rapid prototyping, also called gray boxing, directly within the editor of your game engine. So you can create your blockouts and hit play to directly experience your level, leading to fast iteration through immediate playtesting. As for environment design, we use 3D modeling tools like Blender, which offer tools for modeling, sculpting, or topology, UV unwrapping, and creating materials and textures. But for textures, you might want to use something more specialized like Substance Painter. As for 2D games, you have tools like Sprite or Krita, which can be used for pixel art sprites, and you can also use Spine 2D for animation. The tools for environment design are pretty much the same tools at the disposal of artists. Now let's talk about iteration speed. For level design, the iteration speed is very fast and the process itself is highly iterative. In Unity with ProBuilder, you can make very fast adjustments to your layout sizes and placement based on player feedback. This promotes a fail-fast approach. Player feedback can come from yourself, family members, or a small group of friends. Bigger companies can hire professional testers or even regular people to test, and they monitor how these players navigate levels and then improve parts of the level based on that feedback. These improvements include like moving some geometry, creating or deleting parts of the level in order to make navigation more enjoyable. For game mechanics, tweaking enemy placement can significantly impact difficulty and enjoyment. Sometimes if you place an enemy somewhere, it makes the level incredibly hard to win and almost impossible. But if you just move it like 2 meters away, it can make the level possible. Now let's talk about iteration in environment design. The iteration speed is slower. Making changes to models in Blender usually takes more time. However, great results can be achieved through modularity. For example, by breaking down an office level into reusable parts like different wall sections that can be assembled like a jigsaw puzzle. If you improve these individual parts in your 3D modeling software, re-importing them will reflect those changes across your entire level with minimal changes, which is much faster than creating large monolithic models. One of the key differences between the two disciplines is the emphasis on functionality versus aesthetics. A level designer might create a simple platform that functions perfectly for allowing the player to cross an area. Then an environment designer can take the same geometry and turn it into a functional bridge made of wood or weathered stone with intricate carvings and realistic moss and vegetation. Now let's talk about the technical constraints and how the different disciplines view performance. For level design, it's not crucial to have highly optimized models. You can break 3D modeling rules to create geometry as fast as possible, allowing for overlapping vertices or geometry and ugly looking meshes with bad topology under the hood. This doesn't really matter because these meshes are deleted later. The focus during level design is on functionality first. However, during environment design, the focus is on the optimization of rendering. In Blender, this involves meticulously managing polygon count, texture resolutions, and the number of materials that is used. You might need to create low poly versions of your models with different LODs to prevent negative impacts on frame rate, especially when you have all the environment elements in place in your game engine. Now let's talk about player guidance. When you make your level, you want to guide the player towards objectives. In level design, this is somewhat limited. You can use some simple shapes and lighting cues, such as a brightly lit doorway or colored lights. However, during environment design, this guidance is reinforced through visually appealing and art-directed elements. For example, in the Mirror's Edge games, doors are bright red and parkour platforms have bright colors that immediately draw the player's eye. Now let's talk about collisions and nav mesh generation. In level design, you have to consider the navigability of your areas, both for the player and for NPCs, while environment design isn't directly concerned with the collision shapes of the models. Now, after level design and environment design are done, now the job is handled by a technical artist, taking pre-made models from environment artists, assigning proper colliders, and ensuring they fit well with your nav mesh system. When models are imported into Unity or Unreal Engine, the actual physical collision shape might be different from the artist's shape, which is important for games heavily reliant on proper collisions. For example, bullets being blocked by environment props in a first-person shooter. Improper collision meshes can lead to frustrating player experiences. For example, Valve's emphasis on managing collision shapes in Counter-Strike 2 highlights the importance of this aspect, especially given the fact that Counter-Strike 2 is a multiplayer first-person shooter. If you're working alone, it makes sense to wear different hats for each discipline. You can start by creating geometry and testing mechanics, ensuring everything in your level works as it should. Then you can move on to creating the environment art, either by using purchased asset packs or custom models, or by hiring an artist. Afterwards, you would switch back to level design or technical design to take care of collision meshes, nav mesh obstacles and elements contributing to nav mesh generation, or even lighting if you want to bake the lights of your level. I hope you enjoyed this overview of the differences between level design and environment design. This is part of my overview videos on the different processes in game development concerning game design, level design, environment design, programming, art, and more. Also, I just launched the Discord of the channel. You can find the link in the description. So come join us and let's have a chat. Thanks for watching. Bye bye.